Hi, welcome to my next series on machine learning. And in this video tutorial series, we'll look at supervised learning and how to train a model of a supervised learning. And the key takeaway for this video tutorial is training a model using logistic regression and K-NN classifier, and then making predictions using the trained model. So in the previous video, I have already explained the basics and the introduction to machine learning, an overview of machine learning, how many types of machine learning are there. And throughout the tutorial, we'll be mostly discussing supervised machine learning. And in the second series of my tutorial, I had already explained you how to download and install and set up Scikit-learn. Scikit-learn is a scientific, it consists of scientific Python libraries to work with data science, which will be using in machine learning. So it is assumed that you already have some knowledge of Python. If not, then I would suggest that there are lots of online courses and online tutorial for Python. So just a basic knowledge of Python is required because scikit-learn library is based on Python. Now let us start Anaconda. So I'll just type over here Anaconda. So I'll go to Anaconda Navigator. I'll just start it. So this is starting up. I've already explained in my previous session like how to set it up, and then I'll say OK, and then let me launch my Jupyter notebook. So I assume that you already set it up. Okay, so it starts my Jupyter notebook. So I've already explained about Jupyter notebook in my previous session. So if you have forgotten or if you want to revisit, you can revisit my previous video to refresh. Okay, then I'll open one notebook. So I already have one notebook prepared. So I'll just go to, say, I've kept it here. Then I'll go to machine learning folder, and then I'll open this notebook. I've got one notebook called Predict Iris notebook. So in this we will see, we'll just use the same example of iris dataset for which we already have some data, and just predict, make a prediction, train our model and make a prediction over that model. So let me just open it. So this is my notebook, and if you look at it, if you look at this photograph which I have taken from the net for this iris, and I've already explained a little bit about it in my in one of my previous session, so I'll not be going through that again because it will be redundant. So if you want, you can revisit those videos. So we already know that this iris data set consists of the sepal length, petal length, okay, sepal width, and petal width, and there are 150 such records being observed, already being there by the statistician who had already taken down the data, and from that we can train our model and then we can predict. So we'll look at how to do it. Now let me maximize it. Okay, so this is a very famous iris data set. It is like whenever we start with some machine language programming, it is like a hello world of machine language programming. So we already have got 150 such records, and that record consists of sepal width, petal width, sepal length, and petal length. And depending on that, it is the outcome is mentioned in that record, whether it is iris versicolor, iris setosa, or it is virginica. Okay, so first let us import this iris data set. Okay, now in Python we can import a function from a particular module or library. So if you are using scikit-learn, then there are lots of data sets already embedded into it. So or even you can import it from the direct URL also from the its UCI repository. So what I'll do is I'll just take it from the Scikit-learn dataset module only. So from Scikit-learn datasets I import load iris. Okay, so just select this cell and just run this set. Okay, so this gets executed, and the next step is like now I have got this this iris dataset included. Okay, I have loaded this function, load iris function. Okay, this will help me load the iris. Okay, so I've just included the function load iris. I have actually not yet included the dataset. I'll be including it now after executing this function. So I take a variable called iris and I'll run this load iris function. So after execute it, then this data will be loaded into this variable, into this variable iris. Iris variable assigned to the loaded data. So let me execute it. Okay, so this gets executed. When this cell gets filled up with the number, it means it has executed. Okay, now next is let us check this if the data has been loaded or not. So let's take a variable x. So generally we take x as the variable. Okay, we write it as a capital X, but anyway you can take any name you want. So as a general practice we take x and then y we take small. So this is just the vector notation that we take. So x is equal to iris.data and then print x. So let's execute it. It will print out the data. Okay, so you see over here, so we get all these data, okay, which is as a numpy array, which comes as a numpy array. Okay, so you see these four features are there, these four columns are there, that is the sepal length, sepal width, petal length, petal width, okay, in centimeters. So if you scroll down, you'll see there are actually 150 such records. Okay, now next we'll print the shape. Now what is a shape? Okay, shape is nothing but it contains information about total rows or records, we call it, and features, how many features are there. So we know that there are 150 such records or observation. There are many names for this, so we'll call it observation instead of records or rows. Okay, so 150 such observations are there. Each 150 observation consists of 4 features, means 4 columns, and there's one more column that is for the response column, which you'll see later on. Okay, so I'll now print the shape. So let's print the shape. So the command is iris.data is already there, iris.data.shape. So iris.data will give you this data and data.shape will actually give you the shape result. So after execute it, I get 150,4. This means that this iris data consists of 150 observations or records and 4 features or 4 such columns. So these features are nothing but independent variable. Like when we write fx means y is equal to fx, y is as a function of x, where x is the independent variable and y is the dependent variable. Okay, so more about it in the later feature tutorials. So today in this tutorial we'll just scope it till training a model and predicting. Now if I say target, iris.target, okay, target means the response, means the actual outcome. Like if we go back, if I just scroll back over here, okay, so these 3 species, okay, this species versicolor, setosa and virginica, so these are the target or the outcome or the label, whatever you call it, response, we call it response also. So these are response or target. So this is the outcome. We'll be predicting based on the data, based on what width, height we have for sepal and petal. So it can be either of these three species, which we technically in machine language terminology we call it as response or target or outcome or class. Okay, since this is a classification problem, it is a supervised learning classification problem. So these are the 3 different classes. Okay, so outcome can be either of these 3. Okay, so yes, sorry, I just scrolled it. Okay, so the outcome is either of these three. So now I scroll back. Okay, so now I'll print. I have already print shape. So these are just the terminologies which you need to remember. So now we will print target or response. Okay, so we know that there are three types of response or target which we have seen, three different species. Now there's a rule when you're working with scikit-learn that this target or response should be numerical. It should not be the name like Virtus, the Virginica, or the different species we have seen, or versicolor or setosa. It should be encoded in numerical format. Okay, then only we can actually implement it. So if I say print target, means print y is the variable consisting of iris dot target, whatever is written by iris dot target. So let's execute it. So you see this target, so there are 150 such values. So you see 0 0 0 1 1 1. So there are three different species. So for first species it is 0, second type of species it is 1, labeled as 1, and third species it is labeled or encoded as numerical value 2. Okay, and if I print the shape of it, so we already know the shape of it is 150. There are 150 such instances. Okay, so here you won't get this 4, the value 4. Okay, 4 is for data dot shape. It is 150 and 4, but here it only consists of 150 rows. Okay. Okay, as I mentioned, target is also known as response or outcome or level. So anyway, we'll call it response. Now, even you can print it by name, the feature names also. So if you just say print iris.target underscore names, then instead of 0, 1, you'll get the category. What are the three categories? So setosa, versicolor, and virginica. So 0 means setosa, 1 means versicolor, and 2 means virginica. Okay. So now moving on to the next. Okay, there is a rule, as some of the points I've already mentioned, that response and feature should be numeric and should be a numpy array and should have a specific shape, and these should be, response and feature should be separate objects. Response should be one object, feature should be different object. Okay, as we have seen over here. Okay, response and feature we are taking it as separate object. So this is one separate object and this is one separate object. These are the features, separate object, and here we have got response, which is the separate object. Okay, and we predict for this what will be the response. This is what we predict. Okay, so now let's start the step for predicting using KNN classifiers. See there are different algorithms, different algorithms which you can use for your model. Okay, like decision tree is there, random forest is there, then you have got KNN classifier, K nearest neighbor, you have got logistic regression. Now one more thing, when I say logistic regression, that doesn't mean it is a regression model, it's actually a classification model, but we call it logistic regression. When we say linear regression, then it is a regression model, linear regression, but not logistic regression. That is actually a classifier. So let's start with KNN classifier. Now in short, though KNN itself is a separate topic altogether, it is vast. If you want to learn it from scratch, then there are lots of tutorials online. But in a nutshell, let me just explain you this diagram, that when we already have this data point available, like say yellow one, this also I have taken from net. So if this yellow one is actually your class A, say for example, say we are predicting either this is class A or class B based on some data in 2 dimensions. Okay, so if x2 is a variable, based on x2 and value of a x1, we can measure the outcome. So this is class A, all the yellow ones, and blue one is class B, and suppose this star is the one which we need to predict whether star will belong to class A or class B. Okay, so here we have to see which is the nearest, which is the closest point. Say if we are taking nearest neighbor as 1, the value of k is 1, say for example, then it will measure the distance from this point to this point, this point to this point, and this point to this point. Say if this is the nearest, this purple is the nearest, then with the value of k is equal to 1 and using KNN classifier, then the star will predict that the star belongs to class B. Okay, because this is the nearest. If the value of k is equal to 3, that means so 3 nearest neighbor it will take. Okay, so if it is taking 3 nearest neighbor, if you see this circle, it is surrounding 3 points, the 3 nearest neighbor point. So if you see that 2 nearest neighbor is purple and 1 nearest neighbor is yellow one, that is class A. So which one should it predict? What will be the prediction, like this belongs to which class? So there will be a score. So the score is higher for class B. It is 2. There are 2 class B which is nearest and there is only 1 class A which is nearest. So the prediction will be that this belongs to class B. So for k is equal to 1 and k is equal to 3, it will say that it will predict that this star belongs to class B. Now what happens if we take k is equal to 6? See this circle. If we take k is equal to 6, so 6 nearest neighbor, 1, 2, 3, 4, 5, 6. So in this case we see that the nearest neighbors, class A, there are more number of class A as a nearest neighbor as compared to class B. Okay, so when we take the parameter k is equal to 6 for KNN classifier, then our prediction outcome changes. It becomes class A. Okay, so this is how a k nearest neighbor works. Now you'd be wondering then that which is the actual more accurate classification, taking k is equal to 6 or k is equal to 3. That we'll see in the future videos, where we'll see how we can predict how we can measure accuracy, how can fine tune a model for more accurate prediction. So there we'll learn about it. So right now let us take some abstract value of k, any value of k we'll take, and we'll just use it for prediction, just for the learning purpose. Okay, now how to apply this k neighbor classifier? Now see, if you already know the algorithm of k nearest neighbor, you can use any programming language and you can write your own logic. But if you are using Python's scientific libraries, or if you are using R programming language or any other programming language scientific libraries which they have already provided this algorithm, then you don't need to worry about writing the whole logic on your own. It is already given there, so you can focus more on the implementation rather than writing the whole entire logic. Because even if you write the logic, then maybe that your the performance of your logic is not that much optimized. Then again you need to check how to improve the performance. Instead you already have it available, so you can directly use it. Okay, so you can focus on implementation. So we'll again import this function, kneighbor classifier function, from this module, scikit-learn.neighbors module. We import that, and then we take a variable, say KNN, and we will run this function. And let's run this function with n neighbors. N underscore neighbor is one of the parameter, is equal to 5. There are other parameter also which takes a default value if you don't provide any value. So let us take is equal to 5. You can take 1 also. You can experiment actually, and later on we'll see that which value is the most optimal value. But for now, just for the sake of simplicity, let's take any arbitrary value. Okay, so I'm taking this is equal to n neighbor is equal to 5. So first let's execute this. So this is the advantage of notebook. You can execute cell by cell instead of executing all at once. So, and a very handy tool for data scientists. Okay, so now that function is being imported. Now we can use this function. Okay, so we run this function with n neighbors is equal to 5. Now I'll say print KNN. So let us see what is the value of KNN, because KNN already is being assigned the return value of these functions. So you'll see all the parameters. Okay, so this k neighbors classifier, see algorithm is equal to auto, leaf size 30. So all these are default parameters which we are not using right now. Only the parameter we provided is n neighbors is equal to 5, which it has taken. Otherwise it has taken all the parameters as default value. Okay, now this was the classifier which we have executed. or with n neighbor is equal to 5. Now we need to train. Okay, now comes the next step is to train the data. So what are the steps? First is get the data, which we have already done. We have got the data. We already have the data from the previous previous commands which we have executed. So we got the data, then we train the data. There is also a part before getting the data, there is a role for the data scientist to actually clean the data. So we are assuming that this data is clean. Whatever data we have got is already cleaned, so that step we have already skipped. Okay, so after that then we need to train the model on this data. Okay, so we run this classifier. We have selected the model, which model we want to go for. Then on that model, fetching this, so we providing this data, we train the model. So the API for this is called fit. And one very good thing about this scikit-learn is that these are consistent, that this API is standard and they are consistent. Even if I take another classifier, there also if I am to fit the model or train the model, it will be the same. The API will be same. There also will use fit. Okay, they also will use predict over here, which we are using. Okay. Okay, so let's train this model. So x and y. So this we already seen what is x and y. Okay, they are the data and the sorry means x is this all the features which we have is x, that is the iris.data, and y is the response. So providing the feature and the response, we are training the data. Okay, so we are providing the feature and the response, and then we train the data by using this fit command. So let's execute it. Okay, so this is trained now. This model is trained now. Once the model is trained, then it can make prediction. Okay, so now we are having one data in a sample data in question, or the data in question, for which we need to know the outcome, that if the sepal width, height, then petal width and height are 4, 5, 3 and 1 respectively, then which species does this belongs to, then what is the species of that flower. Okay, so remember that this should be a numpy array. So this array within an array, it will be something like this. Okay, so don't forget this. And then we will say that predicted val, a variable will take, and we will say knan.predict this variable, and the method predict will run upon this input data, and then it will predict me the value. Okay, the predicted value will be stored in predicted val, and the next cell will actually print that the prediction is whatever is the value it has predicted. So it will predict a numerical value, right? So iris.target underscore name, we already seen that there are three different species. 0, it is an inside an array. If I say iris.target underscore names, it is an array. 0th one is setosa, first one is versicolor, and second one is virginica. So this return value of predict will actually give me 0, 1 or 2 based on what is the outcome. So that if we that 0, 1 and 2 is the value. Okay, so first let's run it, then it will be easy for me to explain. Okay, so predicted val, okay, it runs. So let's first print predicted val, then it will be more easy to understand. Print okay, so let me execute this. Let me print first the predicted val. Okay, so it has predicted the value 0. Okay, it has given us the value 0. Fine. That means it is this 0 means setosa. Okay, okay, so one more thing I'd like to tell you, like we can even here have multiple inputs at the same time. Okay, say I've got something, say 3, say width, height for both the petal and sepal. Say let me take some random values, say 3, then 1, then 2, then 2 for example. And now if I execute it, so you see we get two different values. Okay, for both. First one is for this, second one is for this, and so on. So this means we can give multiple values as well. So now let's re-execute it. Oh sorry, I missed out something. Okay, the close bracket I have deleted by mistake. Okay, okay, so it gives me this output, so 0. So now I can print it. You say that print, say the prediction is that this is the string message concatenated with the value. So we know that iris.target underscore names consist of an array of the names of the species. Okay, so we'll say predicted val. So this is the predicted val and the 0th index of it. Okay, this 0 doesn't mean this 0. Okay, so the 0th position, whatever it has got at the 0th index, that is the value. So the value itself is 0 over here. Okay, so let's execute. So it says it is setosa. Okay, and say if it was something like say instead of this, say if I had say 2, then 3, or say 1, and say if another one also as randomly we are taking some value 2 and 1 for example. So let us just execute it. Okay, it is giving the same setosa. So you can just randomly give some value and just try it out, like what are the predictions it gives. Okay, so this is 1. Now if I run this, okay, so it is vertical. Fine. So we have trained our model, so it is very simple, like if you are using Scikit-learn, because all the models, everything is implemented, just need to implement that model. So we have implemented KNN with k nearest neighbor is equal to 5. So you can keep changing the parameters and just try to play around with different values. So if I say k neighbors 1, then again I need to run it over here, then print KNN. Okay, this is not required, but anyway, then you train a model over this with a value of k neighbor is equal to 1 and see if there is any difference or not. So now there is a difference with n neighbors is equal to 1, you get the prediction as species number 0. Okay, which is species 0 means it is setosa. Okay, and if I take neighbors is equal to 5, then we have a different species. Okay, so in the next tutorial we'll learn like which one is the accurate prediction, how to choose that which parameter is the best, the optimal parameter, that we'll learn later on. So for now this should suffice. Fine, so this is how we implement the KNN classifier. Okay, with nearest neighbor value as 5. Okay, so what are the steps? The step is train the model using the fit method and then predict the model using predict method. Okay, fit and predict, these are the two methods that we have used. So it's very simple, the implementation is very simple. Okay, just fit and predict. So now let's look at logistic regression the same way. So as I mentioned that the best thing about Scikit-learn is that its API is standard and consistent. It doesn't changes with classifier. So here also we'll be using the same fit and predict. Okay, same way we can use. So first let's have a quick look at what logistic regression is. So it is logistic regression, nothing but you can say a linear model or a linear model which is modified to make a logistic regression. Okay, the reason is that, say for example, you see this blue line. Okay, this is a linear model. Okay, so now this model can even have a negative value also. So if it is a linear regression, then this linear model is fine, because we know that in linear regression the outcome is continuous, it's not discrete. Like for example, the outcome can be a salary of a person, so it can be, say the salary can be $4,000 or it can be $5,000. So it is continuous, it can be for $4,999. Okay, so it can be continuous. But in this case, like in iris dataset, This is a case of classification. This is a classification problem. This is not a regression problem. So here we need a discrete outcome. Okay, either it is a species 0 or species 1 or species 2. Okay, so in that case we need the outcome either as, say for example, in this is a very simple diagram, the most simple one for diagram for logistic model which is being taken. So in this case, like if this equation is modified this way, raised to the power of e, though discussion about this deduction of this equation is not in the scope of this tutorial, but you have lots many links and lots many tutorials online. If you are interested, you can have a look at it, how it is being deduced. So final formula is this, okay, where it is raised to the power of e at v0 plus v1x raised to the power of negative power as a negative power of e, 1 plus negative power of e. Okay, so this way what happens is, if you see that if something is its tendency is becoming negative or moving towards negative, then it should remain as 0. If you see this curve, if you go on reducing the value after this, it doesn't reduces further, it will remain 0. It tends to 0 and continues to be 0. And if you increase the value, then after a certain point, say if you increase its value more than 1, it will remain as 1. Okay, but in the case of linear model, you see what happens if you decrease the value further, means if you decrease the value even lesser than 0, then it will become negative. Increase the value more than 1, it will go to 1. It will become more than 1. But suppose our outcome is only 2, for the sake of simplicity, either it is 0 or it is 1. So though in our case it is 3, we have got 3 classes, but just assume that you have got 2 classes. Say an example of an email is spam, whether an email is a spam or not. If it is 1, it is a spam. If it is 0, it is not a spam. Okay, so suppose some value in between. Okay, if the value is over here, somewhere over here, we'll make it 1. If the value is lesser than this, throughout this we'll keep it as 0. So this way it becomes a classification model rather than a regression model. So this is the advantage of it. Okay, so more of it we'll cover later on. I'll be coming up with more video tutorial focusing more on the algorithms as well. Okay, so now same way, if you see, it is exactly the same way we implement any other model, like key neighbor classifier we implemented. Same way we will implement this logistic regression classifier also. So I'll say from Scikit-learn.linear model, import this function called logistic regression, and then we take a variable called logreg is equal to logistic regression. We run this function, and so we get the reference of this model, and then we'll say fit. Fit means, as we discussed, fit means train the model. Okay, so first let's execute it one by one. So I execute this. Okay, the next line I execute this. So we get this function logistic regression model reference. We get it by executing this function, and then we will fit this model. Fit this model means train this model. Train this model by providing the data in the response, feature in the response, x and y. So capital X and small y we write because of the matrix notation, vector notation, I mean vector matrix notation. Then predicted val is equal to, say that for example, if we take a different value, predicted val 1 variable is equal to logreg dot predict input data. So input data, we are using the same data over here that we have used here, input data. Let's see if we are using this model, then what does this predict? Is it predicting the same sample or a different sample, different class, I mean. Okay, so we have run predict. Now let's print this predicted result. Okay, so it is saying the prediction is versicolor, and if you are taking this model, it is saying the prediction is versicolor. Okay, so more or less it is the same over here, but only the difference arises. So we can use either of this model in this case. Only the difference arises the moment I make it some other value, say 1. Okay, so if we make it 1, we have already seen what happens. So it will say it is setosa if you make the n neighbor as 1, and in this case it is saying that this is versicolor. Okay, so both the case we are making a prediction, but which prediction is more accurate or more near to accurate, that is the next topic which we will see in our next session. Okay, so in this session we have just learned how to predict, And then after so many models, so many different parameters, so how do we conclude that which is the best fit for us, or which is the optimal prediction for us? Okay, so that we will continue in the next tutorial, where we use cross validation, and we will check on the further concepts related to that. So I hope this was fruitful learning for you, and thanks very much for watching. And I'll come up with the next video very soon. Thank you. Bye bye.